We're live. All right, we are live. Okay, 5/13/19. Okay, so today, story problems. Everything starts from this. You need to find some right triangle. So we need a right triangle. Now, when I look for a right triangle in a story problem, sometimes they talk about these things called angle of elevation and angle of depression. But everything comes from the horizon. From the horizon, okay? The horizon is the flat, right? The horizon, so an angle of elevation would be the angle that goes up from the horizon. That seems simple, doesn't it? And an angle of depression starts from the horizon and goes down, okay? You guys want to sit outside? You guys going to be good?
I'm good, sorry.
Thank you. Okay? So, angle of elevation. Let's just draw a picture. Comes off the horizon. And it's the angle that lifts up from the horizon. There's my angle of elevation. Okay? So let's look at example 1. A 6-foot man sights the angle of elevation to the top of a building to be 64 degrees. If he's 100 feet away, how tall is the building? So, first of all, try and find a right triangle. So that's the key to this thing. So I'm going to go ahead and draw a picture. I'll put my 6-foot man here, and he sights the thing. It's just hanging out. And here's my building, right? Now when he sights it from his eye. So the triangle I'm drawing is really kind of suspended. It's suspended from his eye all the way across the horizon. My 64 degrees is here because that's my angle of elevation, right? He's 100 feet away, so this 100 here from the building, it's also here for the triangle. Now the triangle is suspended 6 feet above. The triangle I'm drawing is 6 feet above because that's how tall the man is, right? So when I'm done with this problem, I'll have to add his 6 feet in, okay? When I'm all the way done, I'll add a 6 feet in. So if I look at the building, I'm going to call the building X. With the 6 feet I'll add in at the end, right? Okay, this is not hard, so let's go through what we always do. First of all, always pick an angle. Start with the angle. Always start with the angle. So there's my angle. Start with your angle because then your names happen after you pick your angle, okay? So the names we're looking for, sure, those are like the opposite, the adjacent, hypotenuse. We want to label our triangle, okay? So if I label my triangle, I know, let's see, that's a 90. So this is my hypotenuse, which I don't need. That's my hypotenuse, which I don't need. I don't care about that one. This is my opposite, which I do need, because that's what I'm trying to find. And then standing next to him is the adjacent. Adjacent means next to, so there's my adjacent. Okay, so these are the two things I want to work for. I want to work with my opposite and my adjacent. Okay, so then I don't care about the hypotenuse. It's irrelevant. So I look up there, okay, I need the one that is the opposite and the adjacent. Okay, and that's got to be, and that's got to be tangent. You guys see it? So I'm going to use my tangent. Now it says tangent of theta equals my opposite over my adjacent, right? But this little symbol theta is my angle. So theta is my 64, okay? So instead of writing theta, I'm going to write 64 because that's just the symbol for my angle. So I'm going to go tangent of 64 degrees equals my opposite, which is what I want to find, right? So just call that x, over my adjacent, which is 100, okay? Now, provided I'm on the right mode, so always check our mode. Out of mode. So I know right now, you guys, it's pretty important you check your mode because my pre-calc kids, my Algebra 2 kids are doing the other mode. So I'm checking my mode real quick, and I'm gonna check my mode. Okay, mode. I'm in degrees. That's where I need to be is degrees, not radians. Radians is really gonna mess me up. Okay.
How do you check that?
I hit the. It's called mode. Go to the mode button. So it's right there. Hit mode, and it's. The degrees are highlighted. If the radians were highlighted, we'd be in trouble. We don't want to do that, okay? So we'd highlight the degree mode, and that's what we're going to do, okay? So then I'm just going to go ahead and solve this. I'll multiply both sides by 100. I'll multiply by 100. And I'll just use my calculator. And I'll say, okay, what is 100 times the tangent of 64 degrees? And I get an answer of about 205. About 205. 205 is the value of x. Almost done. Almost done, because that's 205 from here to here. So I add in the height of the man, add in his 6 feet, and I get 211 feet for the height of the building. Okay, show me thumbs up. Yeah, here, good. Are you sideways? You're down. Okay, all right. Okay, all right. That's all right. We'll keep working at it. Okay, good. Okay, let's slide it up. Okay, so we just did an angle of elevation from the horizon up. So if we do an angle of depression, that's going to be from the horizon down. So angle of depression, here's my horizon. And then, so if an airplane's flying along parallel to the earth, right, and starts to go down, that'd be an angle of depression. Does that make sense? So angle of depression would be there. Okay, that's my angle of depression. But everything starts from the horizon and then down. Okay, so example 2, an airplane flies 5,000 meters in the air, begins a descent to the airport at an angle of depression of 10 degrees. Okay, how far is the plane from the airport? Okay, so let's go ahead and draw a picture. So again, I'm looking for a right triangle. Here's my airplane. Okay, and I'll put my airport way down here. Here's my airport. Okay, there's my airport tower. So the airplane's flying. It's going to start flying down. Now we got to be careful where we put the angle. So if I draw the horizon, here's my horizon. Okay. Then my angle of depression is there, 10 degrees. Yeah, Derek.
Could you have it go straight down and then have it go to 80?
Nice. Yes. Hold that thought. Awesome. Yes. So let me go ahead and finish, and then okay, I'll show that. So here's my right triangle. Okay, and then this is 5,000. Now Derek drew it a little bit differently because he thought, well, really, here's the airplane. I mean, this is a little weird to put the 5,000 here, right? It's kind of weird to put the 5,000 there, but that is 5,000 in that triangle. But Derek thought, well, what if I did it this way, right? And then if I did it this way, then the 5,000 here makes just as much sense, right? And then you can make that 80 degrees, or you can make even that 10 degrees, right? Nice job. So, what do we need? I need this distance, because it's the airplane. We're not talking about the ground distance. We're talking about the airplane distance, right? So, I'm going to pick an angle. Okay, so how about we just use, how about we use Derek's triangle? You guys want to use Derek's triangle? Does that bother anybody if we use Derek's triangle? Okay. So, 80 degrees, right? I know 5,000, and I want to find x. Okay, so let's look. So let's give some names to what I have. So if I give some names, from the angle, that's my adjacent side. From the angle, this is my hypotenuse, right? So if I take a look at what I have, all right, let's check it out. Adjacent hypotenuse. Adjacent hypotenuse. It's got to be one of those three, right? Adjacent hypotenuse, cosine, right? Cosine? Okay. Adjacent hypotenuse, so cosine. So we'll set up cosine of theta, but theta means angle, so how about cosine of 80? Cosine of 80, because that's where the angle goes, equals the adjacent side, which is 5,000 over x. Now this is where you're going to have to divide. X on the bottom, so that's where we're going to have to divide. So what I'm going to do to solve it is I'll multiply by x. Bring the x up there, okay? So if I multiply by x, I'm going to get x times the cosine of 80 equals 5,000. Okay? Okay, just like solving anything, I'm just going to divide. Now I'm going to divide by cosine of 80 because it cancels it. Cosine of 80 cancel. Divide by cosine of 80. So this time, so when the variable is on the bottom, you're going to divide, okay? So, all right, here we go. Now I'm going to go, all right, let's check it out. Clear. I'm going to go 5,000 divided by cosine of 80, and I get an answer of about 28,793.9 meters, okay? How many miles is that? Well, we can divide that by, close to 1,700. Now we get how many miles. But that's a good enough answer, okay?
Wait, so if you times it by 3, that's it, and divide it by 1.
I would divide it by 3, give me
Wait,
Get
divide by
close.
3.
Or we can convert it. We can convert it to meters into
Multiply by
yards.
3 to get your feet, and then divide it by how many feet in a mile.
Yes. Okay, which is 5,280. Right. Okay. Thumbs up. Okay. Turn the page. What'd you get?
16 miles.
That makes sense, doesn't it? Yeah. Okay. Turn the page. Okay. Example 3. Find the area and perimeter of an isosceles triangle with a vertex angle of 40 degrees and a base of 12. So let's draw a picture. Okay. Isosceles means these two sides are equal. Okay, it's got a vertex angle of 40 degrees, right?
What you says are equal to 2 slanted ones.
Yeah, these two are equal, aren't they? Yeah, totally. These two are equal. So I don't see a right triangle. That's okay.
I'll make one.
Let's make a right triangle, huh? So if I don't see a right triangle, let's just make a right triangle. So I'm going to go ahead and cut it right down the middle. You guys okay with that? Okay. And here's my red triangle. I'm just going to redraw that red triangle over here because I want to change some things in. Okay, so here's my triangle. So I'm going to redraw this triangle. This is 6, and this is 20, right? This is also 70. Okay with that being 70? I don't know if you need it, but I put the 70 in there because I know these two have to add up to 90. Okay, so I've got to find the perimeter and the area, right? So first, let's find this side. Let's call it X. Because if I get that side, then I got the other side. I get the perimeter, right? So if I get this side right here, right? That's that. That'd be X there and there. So if I get this side, I got that side, right? If I get this side, boom, I got that side because it's isosceles, right? And then I can go that plus that makes my perimeter. Okay, thumbs up. Okay, so this is X and this is X. So let's just deal with this formula. Okay, so now let's think. If I use the 70 or the 20, it doesn't matter. Abby, what do you like? Which angle? 20 or 70? Which angle? Doesn't matter to me. Which angle do you like, 20 or 70? Abby, which one do you like? There's no wrong answer. Which one do you like, 20 or 70? 20 it is. Awesome. So we're going to use opposite, right? Hypotenuse. Let's use the sine. Opposite hypotenuse, let's use the sine, okay? So let's set up sine of 20, because that's the one you picked, right? Equals the opposite, which is 6, over the x. Let's shortcut this a little bit. Now we just learned that if the x is on the bottom, we divide, right? Remember that? The previous problem, the x was on the bottom, and we ended up dividing, right? So let's do the same thing. Let's have x is equal to 6 divided by sine of 20. Okay, let's see what I got. 6 divided by sine of 20, and I get an answer of about 17.5. Okay, so x is about 17.5. Okay, cool. Let's go back and see what I have. So I go back to my triangle. 17.5, 17.5. Okay, so far so good, right? So perimeter, I can do that one. Perimeter, let's see, equals 17.5 plus 17.5 plus 12, right? Perimeter, I'm just going to add all the way around. So I've got my perimeter 17.5 plus 17.5 plus 12, okay? I'm just going to put my in. 17.5 times 2, 17.5 times 2 plus 12, and I get an answer of about, oh, that's not even close. Let's do it again. 17.5 times 2 plus 12.
47.
Thank you, Derek. 47. So I got an answer of 47 centimeters, okay? Problem's not done, but thumbs up so far. That wasn't so bad. Okay. Now, to get area, let's see. How do I find area? Area is 1/2 base times the height of a triangle, right? Okay, let's see what I got. I've got area equals 1/2. I know the base. I do. So area is 1/2 base times height. I know the base is 12, right? The base is 12, but I don't know the height. Well, let's call it h and go back to this right triangle right here. See, I need to know the height. Let's go back to this right triangle right here. Let me get some different colors. So, all right, let's just pick the other angle, just for fun, okay? 70, the H, and the 6. Opposite, adjacent, right? Opposite, adjacent, opposite, adjacent. How about tangent? Okay, I got to find H, right? Because I got to find the height. So let's go. Tangent of 70 equals opposite over adjacent, okay? Multiply up 6, almost there. 6 times the tangent of 70 equals H. God bless you. 6 tangent 70, and I got an answer of about, 16.5, right? So I got H's, I got the height to be about 16.5. Okay, I'm almost done. Almost done. I've got the height of the triangle. Okay, it's 16.5. And then finally, to get the area of the triangle, let's get the area. I'm going to go, and I get,
times 6 and
I got 99.
oh yeah, 99.
That's, I believe, it 99. I'm glad you're up here. Centimeters squared. Okay, so before I move on, let's go back through it. Okay? So you kind of get the idea. So let's go back through it. So I have to have a right triangle. Agree? Got to have a right triangle. I made a right triangle. Okay, here's my right triangle. Okay? I found this side because I was a hypotenuse by using the sine. Then I had to find the height, which is the height here, right? And I've done the height by using tangent. So then the perimeter is easy. Just plus, 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 because I found that side. And then the area is easy because I've got the base already 12. And I just found the height. Which is 16.5. Okay? Now, last but not least, okay? Find the area of this regular pentagon. Again, we've got to have a right triangle. So I'm going to start right here. In this pentagon, there are 5 triangles that are all the same shape, right? So what this problem turns out to be almost identical to the problem above it, except for different numbers, okay? So let's take a look. First of all, what I want to do is find, and I'm going to superimpose this. I'm just going to work with just this one little triangle here, okay? So I'm going to do the same thing with this little right triangle here. Let me superimpose that, bring it up here, okay? I know this is going to be 10, so this is 5. You okay with that? You guys okay with that? That's 5. Now I need more. I need more. But you ready? I'll go around in a circle on the inside. How many degrees? I'll go around the circle on the inside. How many degrees? 360. And I got 1, 2, 3, 4, 5 of those angles, right? So if I want to find a central angle, okay, let's just call it a central angle. So if I need a central angle, I can do that. Heck yeah. So to get a central angle, I'm going to go 360, because I'm going all the way around. Divide by 5, right? And I'll divide that by 2 in a second. So if I go all the way around, 360 degrees, divide by 5, I get 72. Okay, now, 72, though, is not the angle I need yet. Because this whole thing is 72, right?
But isn't that an internal angle, so it wouldn't be 180?
Oh, you know what? If I wanted that angle, yes. And I could do it that way too, Derek.
And then divide that by 2.
Yes, I could do it that way. Yeah, nice job. So what I'm really going to do is divide that by 2 to get 36. So way up here, 36, right? 36, look where my pencil is. 36 right there, so that, remember I superimposed that triangle, 36 there. Okay, now let's check this out. I need the area, so I need the height. I need the height, right? So, pick an angle, 36, right? Let's use the 5, that's my opposite. I got to find the height. That's my adjacent. Oh, opposite adjacent, opposite adjacent, opposite adjacent. Tangent. Tangent of theta, but theta is my angle. So tangent of 36. Opposite over adjacent, which is my 5 over my h. Can't divide by h, right? So I trade places and I divide by tangent. So I have h is equal to 5 divided by tangent of 36. Okay, this problem is on your test. Different numbers, of course, but you know. 5 divided by tangent of 36. And I get an answer of about 6.88. So the height is 6.88. Okay, now let's find the area. All right, so the area of the triangle. Area of a triangle. So I'm going to go area to see this is my little triangle thing. This is my area of my triangle is 1/2 base times height, right? So area of my triangle, right? My triangle, look for my triangle, is 1/2. My base is 10, and my height is 6.88. Okay, how am I doing? We're doing okay?
Well, would you not have to divide by 2 anymore since you already split that?
It'd just be 6.88 times 4.
Yes, yes, shh. Totally correct. Okay, 0.5 times 10 times 6.88. So this triangle, one triangle, the area of a triangle is 34.4. But how many triangles are there? Let's go back to the original figure. How many triangles are there? There's 1, 2, 3, 4, 5, right? So let's just times this by 5, right? So if I want the Pentagon, I'm going to go 5 times my 34.4. 5 times 34.4, and I get a grand answer about 172. And that's in terms of centimeters. Is it centimeters? I never said. Let's just call it centimeters. How's that? Let's just call it centimeters. Okay, centimeters squared. Okay, thumbs up. Okay, now, find